joined. So I want to talk a little about the exam. I don't actually have my hands on them to pass back, but the grades are in Blackboard. I'll bring them on Thursday. But I do have, some information on them I wanted to pass along so you can sort of see where you fit the distribution when you look at the score on Blackboard. Anyway, so I was pretty happy. 40 people got 80 or above. That's about half the class. So apparently coming in here and really scaring the helps. Hate to be motivational in that way, but maybe that made a difference. Anyway, the men's was 16, max was 100. That's great. Average was 73, median, half above, half below, 76. That's pretty reasonable for a course like this. Very reasonable, actually. These are probably, I would never go lower than 90, 80, 70, so these are going to be A's and A minuses depending on where you are. These would probably be, the B range might go a little bit into here. C range is probably going down to here. Once we get down into the 50s and below, then I think I'm starting to worry a little more about how you're doing in the class. And you're probably getting into the D range in the 50s and down. Once you get below 50%, that's not so good. And you're going to need to do better for the next test and for the final. So let me just put it that way. But I have absolutely no reason to complain. I didn't try to make the test too easy, but I didn't try to make it too hard easy either. And so, now one thing that happened is some of you, several actually, I don't know why, you should get all 6 problems, so we had to do that. Fill out the third highest one, and I don't quite know what was going on with that, but I think the instructions were pretty clear, and so if you just try to do 6 anyway, it's supposed to discourage you. Anyway, so some people got hurt by that a little bit. So be sure to read the instructions, and it says do 5 problems only, and if you do 6, this is the big bad thing that's going to happen to you. We're paying attention to that. So yeah, stick with it though, because it's going to keep going on. The other thing I want to talk about is that homework too. I just made a huge error with that homework. It was way too hard. It was just, I should have asked 1 problem maybe instead of 3, and maybe not all the parts of some of those problems. And so that homework was a huge mistake on my part. It set a bad tone. I tried to do better with the review. I think I got you pushed in the right direction. But the rest of the homeworks, and I'll have another one today, if they're that hard again, I'm just going to have to just give you all an A or something, because that's not what I intended. So that homework was a mistake on my part, and I apologize for that. It was too hard. Simply too. And also way too long. It wasn't just that it was hard. Even if you got it, it was just tediously long with no real learning associated with all the tedium, as far as I can tell. And so I apologize for that. I won't let it happen. I was gone until Sunday, so I didn't get him until Sunday afternoon. So he heroically got the grades done, so I could at least get them on Blackboard for you. But we just haven't had a chance to get that together yet. So I'll do my best to bring those on Thursday. So we can pass them. So I'm happy. I always say that. So now we're going to put some pieces together that we used on the test and other places. We'll talk about policy effectiveness. And this is not in the book, but I think it's important. So what we want to know is, when are monetary and fiscal policy more or less effective? And by effective, we mean, when does a given change in monetary policy or a given change, a fixed amount, a fixed quantity, have a smaller or a larger effect on output? So if a certain size government spending change has a great big effect on output, we'll say it's very effective. If it has almost no effect, we'll say it's ineffective. So we're talking about the ability of policies to affect output. We want to know how those things vary over the business cycle. And there's 3 things we've looked at I of I, C of y minus t, and L of I. This was the responsiveness of investment to the interest rate. This was the responsiveness of consumption to disposable income. And this was the responsiveness of money demand to the interest rate. This is probably, I want you to know them all. This is the one that I really care about because I think this parameter varies a lot over business cycles. If this is the one that really varies a lot, it's going to tell us the most about the relative effectiveness of policy. Let's start with that one. Plus, it's a pretty good, easy case. So do you remember when I of I in absolute value goes up, when its absolute magnitude gets bigger, goes from minus 10 to minus 20, the slope of the IS is flatter. And I believe that was on the exam. At least 40 of you did pretty well on it. These are probably the ones here. So we want to start with two different IS curves, a flat one and a steep one, and look at monetary and fiscal policy and see when the changes are big and when the changes are small.
What is the consumption to
disposable income? Sure. Thank you. So let's take a steep IS curve, relatively steep, it's all relative, and a flatter. And just a regular old LM curve, whatever it looks like. So here's our initial level of output. So let's look at monetary policy first and see if we can figure out what's going on with that. We could follow the interest rate, but I want to know about policy effectiveness, so I'm not going to care what the interest rate does, so no sense keeping track of it. So if we let the money supply go up, what happens here? The LM curve shifts to the right. The LM prime. And so if the IS curve were steep, or if the IS curve were flatter, we get different answers. Now, I meant to say, this is the one for I of I bigger. So this is the I of I bigger, and this is I of I smaller. Bigger, smaller might be better than arrows. Get the point. So monetary policy is more effective when investment is more responsive to the interest rate. So, first thing we know here is monetary policy is more effective more responsive. I is more responsive. Not too hard, huh? Why? What's the intuition? How does monetary policy work? You're supposed to know the intuition for the test. When M goes up, I goes down. which causes investment to go up, which causes output to go up. Investment goes up more when I goes down, Y goes up more. So we said, when money goes up, money supply is greater than money demand. So you tell a bond story or say, the price of money falls because the supply went up. Investment goes up, output goes up, and so on. But this is the link we're talking about right here. When this is more responsive, you get a bigger change in Y. So it's because monetary policy works through interest rates. So monetary policy lowers the interest rate, then you need something to happen. You need people to consume more, or people to invest more, or something like that to happen. You need more housing, housing in here too. So mortgages are cheaper, people buy more houses. That kind of stuff. You need that to happen. This is intuition for monetary policy. Yeah, we'll do this one in a minute.
So like a regular, like money that goes up,
If the money supply goes up, the supply of money goes up, the interest rate falls. The price of money falls. Now, what do we say about this linkage in a recession? First of all, if you're at the zero bound, it might be hard to make interest rates go down. Come to that, that's LOI. But if you're in a recession, it's probably the case when you lower interest rates, if you can, it doesn't have a very big impact on investment because you have all this excess capacity. It's all this idle factories and idle trucks and all that sort of stuff. So monetary, it probably goes up when the economy is booming and down in a recession. So this is saying monetary policy probably more effective near full employment, when there's a big investment response to interest rates. In a recession, when there's not much of a response to interest rates, like now, when the Fed lowers interest rates, the money just piles up in the bank, no one borrows it to do investments. That's why there's all this cash sitting in the bank, no one wants to borrow it because the economy's doing crappy, and you already have plenty of stuff anyway. And so you don't see monetary policy having a big effect for traditional channels. Maybe non-traditional channels should get more of the QE and things like that, because the traditional channel tends to shut down. Now, you might do things like give firms tax breaks or other sorts of things to encourage investment, but just if you don't do anything like that, you tend not to get much. Okay, now let's do fiscal policy. Now, this one's going to be a little bit trickier in terms of how you graph it. There's a right way and a wrong way. So again, we want a steep IS curve and a flatter IS curve. And this is the bigger responsiveness, and then we want an LN curve. All right, the setup? The only thing different between these two curves is the value of I of I. Now, I'm going to assert something without using math to prove it, to help us know something. What I need to know is, this is government spending, so I need to shift these IS curves. Should I see this point of intersection? Should I shift it horizontally or vertically? And that's what I need to know. And so for an IS curve, the horizontal shift depends upon C of y minus t. And the vertical shift, the distance, so an increased government spending, how far this shifts depends upon that parameter. It's actually the multiplier, 1 over 1 minus c of y minus t. That is the multiplier. And so you get a bigger or smaller shift depending upon the value of the MPC. In this direction, it depends upon, it's actually, I believe, 1 over I of I. I'm not going to worry about the exact, but it depends upon that parameter I of I. Now, that actually wasn't. So, the only reason these curves have different slopes is because of I of I. They have exactly the same C of y minus t. All else is equal. So they're going to shift identically in this direction and differently in this direction. So in this particular case, I would take this point of intersection and shift both curves out horizontally by the same amount. So I'll get a steep case. Well, let's find y0 before we start shifting things around. There's our starting point. So I'm going to shift these horizontally by the same amount. So I'll get a steep one that goes through that horizontal point. These are supposed to be parallel. I didn't get it very great. So it shifts out horizontally by that amount. And this other curve shifts horizontally by exactly the same amount. So it's just as though I just grabbed that scissor point, lifted it up, and set it down right there. Then I'll either get to that point or that point. It's one of those things hit the L after. So we can see the answer. But I'll let you catch up before I put any more lines on the ground. See how these curves shifted different by vertical distances? That's because I of I controls that shift. But C of y minus t controls this shift, and that's the same. So they shift by exactly the same amount. Because when you take partial derivatives, you shut down the other axis. So this was the flatter curve here, right? That's why I of I bigger. And this is the one here. That's the y of I smaller. That's exactly the opposite of what we got in the last case. In this case, it's the steeper curve or the smaller I of I that makes policy more effective. That's going to make fiscal policy more effective in recessions. Why? This is on your test. When government spending goes up, income goes up. It actually goes up by the multiplier. That's precisely this horizontal shift right here. And they have the same multiplier because they have the same C of y minus t. Then you get crowding out. And how much crowding out there is depends upon the I of I. So when y goes up, money demand goes up. Remember how this works? Interest rate goes up, investment goes down, and y goes down. That's the movement from here to here or there to there. So I of I is right here, right? It's that link. So in this case, when it's big, you get more crowding out. So near full employment, government spending going up tends to just crowd out private investment. In a recession, you don't have that crowding out to the same degree, if at all. Right now, you probably don't have any. And so, when I of I is small, like here, you get less crowding out, and therefore a bigger change in output. This is the offset to from here. We've always done A, B, C. So this was always A to B. This is B to C. Or C, depending which curve you're on. It's a little wider. There's this. It's the same one. I didn't mean for it to be different. My writing just isn't very good. So this says that fiscal policy is probably more effective. So when I of I goes up as near full employment, monetary policy is effective. Fiscal policy is fill in the blanks. So monetary policy, it was more because you get a bigger impact of interest rates falling. This was more, and this was less. Because you have more crowding out, interest rates go up, and you get more and more. So in a recession, what's more? So near full employment, fiscal policy gives you a lot of crowding out, monetary policy probably works. In a recession, monetary policy probably doesn't work very well. Fiscal policy will be more effective because you don't get the crowding out. So when I of I goes down, as in recession, it's opposite. Fiscal is effective, monetary ineffective. Here?
Yeah.
Monetary. Let's go in monetary. I wish I could say those were designed to keep you on your toes. Mostly sloppiness. We could now do C of y minus t. Maybe I'll do that at the end, but it doesn't really have a systematic change over the business cycle that I can cite. So I don't think we're going to get clean results. You would do the same thing except you shift it horizontally, vertically. Because now that I of I would be the same, but C of Y minus T's would be different. But let me do the L of I parameter next. So what did we say happens to the LM curve? So when this goes up, when this goes up, the LM curve becomes what? Flatter, steeper, flatter. That's what I think. But I could have it wrong. I'm just doing it from memory. But the slope is, yeah, that's right. Flat. Let me draw the LM curve with a constantly changing L of I. So suppose the LM curve looks like that. This is the area here with a larger L of I. That's when money demand is really responsive to the interest rate. And this range up here is a smaller L of I. This flat part is called, remember what we said that was? When the LM curve is completely flat. That's when Li is actually infinite. It's a liquidity trap. So let's look at the liquidity trap first. Let me just exaggerate it. Just draw it completely flat for a while. And then. Now this could be, let's do it in a way where it makes more sense. Let's say the LM curve looks like this. You hit 0, interest rates can't go below 0, so the LM curve looks like this. So we can model this as Li equals infinity, a really big Li. That's a completely flat LM curve. I meant to make that a little longer, so I can do that easily. So you with me? So that's the LM curve. If this is the IS curve, then we increase the IS from IS 0 to IS 1. So let's do fiscal policy first. There's no crowding out at all. You get this horizontal shift. Fiscal policy is very effective here. If you put, say the LM curve is really steep. I'll do a different case in a minute. So when the LM curve is flat, it's as though the IS curve just shifts along this flat part. You don't get any crowding out at all. You get 0 crowding out in this case. So you get fully effective fiscal policy in that particular case. So when Y is very low, like in a recession, we're in this liquidity trap, fiscal policy is probably really effective. When the LM curve is steeper, say we're out here closer to full, so we're out here somewhere, it's very steep, and we do the same increase in the IS curve, we don't get a very big change in output. Because you get a lot of crowding out in that particular case. And so the change in output, if this was completely vertical, what would the change be? You'd get zero change. So the steeper that LM curve gets, the less effective fiscal policy is. So I'm doing two cases. I'm doing a completely flat LM curve at 0 and saying in this case, fiscal policy is very effective. If I have a vertical LM curve and do exactly the same fiscal policy, I don't get any effect on output at all. So as this thing gets steeper and steeper and steeper, this is complete crowding out. You go A, B, C. So the crowding out is complete. Here, B and C are the same thing. There's no crowding out at all. And so if we think the LM curve's flat in recessions, and we do, that's another reason to believe that fiscal policy is more effective in a recession. Now, I could have done this the way we did it before, just taken this LM curve, there's the IS curve, this is the bigger L of I. Then just shift them both vertically. Take either that LM curve or the steep LM curve. And you'll see that for the steeper LM curve, you get a smaller effect on output. So you can do it exactly the way we just did it as well. Either one of these ways of explaining this is fine. So we think when you get into these deep recessions, the LM curve gets horizontal if for no other reason than we hit the zero bound for interest rates. And nominal interest rates can't go negative. Because then you borrow an infinite amount of money, you pay it back, you get more. Okay, let's look at monetary policy for this case. Let's start in a liquidity trap. This is easier to do this way. So let's first start here. So we're in a big recession, demand has fallen. So we started out over here somewhere, and then consumption and investment fell because of the recession, and you hit this liquidity trap. Maybe you're at the zero bound, it doesn't matter, you're at the flat part of the LM curve. So the IS curve is here, and you start off at this Y0. If you look at this model and you increase the money supply, what happens is you stretch this LM curve. So when M goes up, you stretch it out. You can keep pumping M up all you want. All it's going to do is pull the LM curve out this way. So what happens to output? Nothing. Nothing. So in a liquidity trap, monetary policy doesn't work. The reason is, I forgot to do the intuition for fiscal policy, so add that at the end. When M goes up, I goes down, I goes up, Y goes up, and so on. This doesn't happen anymore. When the money supply goes up, the interest rate doesn't fall. If the interest rate doesn't fall, nothing else is gonna happen. And so monetary policy shuts down for two reasons. Both of these first linkages get weaker. It gets much harder to make interest rates fall because that LM curve is flatter. And in a liquidity trap, you can't affect them at all. If you're at the zero bound, you can't lower them. That's why they did a lot of QE and all that other stuff, because there's no way they could bring interest rates any lower. It could work a little bit on the long end, but at the short end, they were at zero. There was nothing they could do. If you can't bring this down, even if you can, maybe investment won't respond.
Wait, sorry, I know you just said this, but so in a recession, fiscal policy is less essential, or doesn't work?
More. In a recession, fiscal policy tends to work. If I shift the IS curve, I'll get a big effect. If I shift the LM curve, nothing happens. If the LM curve is vertical, it's just the opposite. Monetary policy works, fiscal policy doesn't. So if I go to the other polar extreme and say, well, what if the LM curve is really steep, like this? Then when I increase the money supply, output goes up again. Fiscal policy, though, didn't work at all. So in this case, monetary policy works, fiscal policy doesn't. So we get these reinforce the results for that is that fiscal policy is more effective in recessions, monetary policies more effective in employment. So both of these parameters give you the same answer. In this case, this linkage is big. You get a big drop in the interest rate for a given change in so you get a big output effect, a big change in the interest rate. Here, it didn't change at all. Oops. That's my break. Let me do the fiscal policy intuition really fast, and then we'll break. Sorry about that. So this is why monetary policy works or doesn't work. For L of I, it's this parameter right here. For I of I, it's that parameter. Fiscal policy said, okay, government spending goes up, that causes output to go up, that causes money demand to go up, interest rates go up, investment goes down, the output goes down. And this was the I of I part. When it's big, it's worse. Now, what's going to be hard to say is when this link here, when L of I goes up, I goes up more. It's because of the slope of the money demand curve. And I don't want to go through it all. But the reason why fiscal policy becomes less effective is because when L of I gets bigger, again, you get a bigger interest rate effect. And because you have a bigger interest rate effect, you get more crowding out. So near full employment, when money demand goes up, you get a great big change in the interest rate. And that causes output to go down. In a recession, this is zero. When money demand goes up, you don't get any effect at all. And so you get a big impact for output because the crowding out is completely shut down. So the size of this linkage depends upon L of I. And yeah. So you get more crowding out in these sections. That was a little harder to see than the others. happens here, sorry, is you have money supply and money demand. And then you increase money demand. How much the interest rate goes up depends upon the slope of the money demand curve. That depends upon LOI. And so when LOI is big, you get this steeper curve and you get the bigger interest rate effect. And because you get a bigger interest rate effect, you get more. Okay, so there's those notes. Okay, so let's take a break. After this, it's going to get easy. I've got videos, so in this case, just remind me of sending this. It'll be next Thursday, but in this case, it'll be next Tuesday. Yeah, or in a case like this, I'll take electronic. Only if it's a reason that is legit. All right.
Right.
Which one? Okay. Okay. Thank you. I'm going to put one out today. We'll be doing a week. Might come in the morning. like that. All right, let's get going. It's gonna get easier now. For a little while. So this is chapter 6 on the labor markets. You're gonna need to stop, okay? I'm getting annoyed if you're talking too much. Okay? I tried to like look you down 3 times already. So let's get going. So we're going to move on to the medium run now. We've been doing the short run. And in the short run, it's possible for, because prices are fixed in this model, it's possible for you to be away from the natural rate of output, the natural rate of unemployment. We'll put all this together later. Now we're going to move to the medium run. And in the medium run, you're always going to be at the natural rate. Then we'll also, towards the end of the course, move to the long run. And the long run is about growth. So it's about what makes a natural rate of output grow or not. So the long run will be growth models. We'll have capital change and other sorts of things. Medium run, we're sort of holding the capital stock fixed and moving to full employment. We're not allowing for economic growth. And in the short run, we're allowing business cycle fluctuations, deviations from the natural rate. So we want to end up, in the end, with a model you're very familiar with, I think, where you have a long-run aggregate supply curve, a Y star. Growth is about how this changes over time. You'll have an aggregate demand curve, which we've been talking about, a short-run aggregate supply curve. So when output changes, we'll be able to move away from the natural rate for a little while. In the medium run, we'll get back to, so the medium run is when you adjust back to Y star all the time. Then the long run will be about how Y star itself changes. So this is all about the medium run and how you get back, how you, for a given capital stock, how you labor adjusts to full employment. So the first thing is to talk a little bit about the labor market and some of its characteristics. So this is 6.1, a tour of the labor market. So what you do is you start with the non-institutional population. So nobody in the military, nobody in mental hospitals, nobody in jail. Those people are left out. So it's a non-institutional population. Sometimes they call it the civilian labor force. And those under, and those over 16. So we just want the, what we're trying to find is the working age population. So making the assumption that, you know, when you're below 16, you don't work much in organized markets, and so we want to count that population as sort of available to work. If you're in jail, you're not really available to work. If you're in the military, we count you differently. You can't really be unemployed. They tell you what to do. And so we want to throw those people out of our population sample. So this is just the available workers. So that population in 2010, so this is all in 2010. The population, this population, the non-civilian over 16, was 300, the total population was 308.7 million. So in 2010, that was our total population. When you throw out the people I just talked about, the non-institutional civilian population, those over 16, that group is 237.8 million. So that's sort of the base workforce that you could, if everyone was working, you know, no one was staying home, taking care of the kids, blah, blah, blah. That would be the number of people working. Then what we do is you break that into two pieces. There's the people who are out of the labor force. And that's about 84 million in 2010. So of the, about a quarter of them, about a third of them, comes in as 24. A little more than a third of these people aren't even trying to work at all. Then you also have the labor force, and that was the civilian labor force. And that was 153.8. Then you can break this down into the employed. These are drawn much better in the book. And the unemployed. So in 2010, the number of employed was about 139 million. And the number of unemployed was 14.8. 14.8 million people were unemployed in 2010. Then you can take those numbers and develop some important labor market statistics. So to get the unemployment rate in 2010, what would it be? It's going to be 14.8 over the labor force. So the unemployment rate in 2010 is 14.8 over 153.8, which was 9.6%. The unemployment rate in 2010 was 9.6. Which is that over the percentage of the labor force that's unemployed. There's also the participation rate. So what's the labor force participation rates? How do you think that would be defined? Percentage of the population that are in the workforce. So that's going to be 153.8. The labor force over the civilian population, 237.8. And so in 2010, our participation rate was about 64.7%. Like I said, a little over a third were out. You could also do the non-participation rate, which is 1 minus that. So about 2 out of 3 people were actually in the labor force, and then about 90% of those were employed. Then you can do one of my favorites for tracking the labor market, the employment to population. So that's going to be 139.0 over 237.8. The book doesn't mention this one. This is the one that most people track, so I was surprised. And that was 58.5%. So of the population out there available to work, a little more than half actually did. Not because they're not necessarily trying. One reason why I like this better than this, and we'll talk about this in a second, the flows in and out of these things. But in a recession, a lot of people could drop out of the labor force. And just because they dropped out of the labor force, unemployment will go down. So a lot of the declines we've seen recently in the unemployment rate are just because the labor force has gone down. The employment population, though, is immune to that effect. So what could happen is as the economy improves, a lot of the people that are out of the labor force and not even bothering to look can come flooding back in to discourage workers. And as they do, that'll drive the unemployment rate up. So even though the economy is getting better, if you get an influx of workers, you're not going to see much change. But if jobs are growing, you'll see this figure changing. And so this tends to be a better measure. If I can get it to come up here, let me show you some of these, just to kill some time here. No. Where's the thingy? So I'm going to try to pull up those employment to population and all those other things if I can.
If you can like average up the labor force, but
What was that?
if you like can average the labor force, but it's like this average, the 8 million like labor force.
Yeah.
Yeah, like
The average would be divided by 50. You going to come on for us? Laptop. Sometimes it has to warm up. Maybe one of those days, is it? Oh, we've got something going on here. Okay, good. All right. That really worked well on the website. Crap. What happened? Didn't trust it. Sorry. Doesn't want to resize right. Let's see if this will work. A little better. One of those days. Wow. Doesn't even want to go to Fred. So we're going to get all the economic data is from Fred. But it really doesn't seem to want to behave itself today. It's slow as it can be. So I'm going to have to give up. I'll do this next time. Then you go to categories. It's supposed to be just like snappy, right? Why is it taking so long? This is not going to work. All right. I'll show you that stuff later. I just wanted to show you what's happened to these indicators over time, especially during the Great Recession. So, from these numbers, how much churn is there every month, say, in the unemployed? So you got 14.8 million people there. What's the monthly flow in and the monthly flow out of the unemployed? Is it big? Is it small? What's the average duration of unemployment? Exactly what does it work? So this is the flow of workers. And it's from 94 through 2011. So I'm going to do 3 circles here. There's the employed, unemployed, and out of the labor force. So this was 130. This is the averages. So these are different. The other one was 2010. These are the averages over these years. So the employed average was 132.4 million. Unemployed, because it wasn't all recession, was a little lower, 8.4. And the out of labor force was also a little lower because it was better times, was 73.3. Now, each month, you get a little loop here of 3.1 million people. So of the employed, 3.1 million people change jobs. They're never unemployed. They just go from one job to another. Not that big of a number relative to the base. You get about 1.8 million people who get tossed into unemployment on average. These are monthly averages. And then you get about 2.1, these were the averages over that period, so those aren't that different, of the unemployed actually finding jobs. And there's also a flow here. About 1.8 million people on average re-enter the labor force and try to find jobs. And about 1.9 million quit looking for jobs each month. So they graduate from college, they gave it their best shot, and they just got home and said, I quit. I'm not looking anymore. Then you have about 3.3 that moved directly to 3.6. So these are people that just get a job without ever looking. They don't spend time in the unemployment line, they just get a job. Or these are people that get fired, they never look. They just drop right out of the labor force. So if you look at these numbers, you can add up the quits plus the layoffs. So in each month, there's about 8.5 million what they call separations each month. Those are quits and layoffs. So these are people who separate and get reemployed immediately. So those are quits for the most part. They quit and got a job immediately. You get 3.6 million here who leave the labor force. So they might have quit, they might have been laid off, and they just left. Then you get these separations of 1.8. And that's where you get 8.5. So you get 8.5 million separations each month. So relative to the stock of unemployed, that's a pretty big number. The average flow out of unemployment each month is all the people leaving unemployment. So it's this 2.1 plus the 1.9. So it's 2.1 plus 1.9. So it's 4 million. So if you take that 4 million over the 8.1 base, it's about 47%. So on average, about half the people that are in the unemployment pool get a job each month. The average duration over all unemployed is about 2 to 3 months, but that went way up in the recession. The duration went way up. You also have in this pool, there's a lot of turnover, but there's also a group of what they call chronically unemployed who just can't seem to get jobs at all, and they have really long durations. But for the most part, there's a lot of churn. I'm at 8.4. It's the unemployed base. So it's the flow out relative to the base. That's what we're trying to calculate. You also get pretty big flows in and out of the labor force. So what's the flow out of the labor force? We need 3.3 plus what? 1.8. There's 5.1 million that flow out of the labor force each month. And there's 5. And then the ones that flow in or join. This should be into. Either employed or unemployed, so they're flowing into the labor force. They were out of the labor force. They're out of the labor force. That's not what I want to say. And the flow out of the labor force flow into this box. That's 3.6 plus 1.9. 5.5. So the point is that there's a pretty big volume of churning each and every month into and out of the labor force and the unemployment pools and all those things. It's not like it's a static pool of people. Very annoyed by this, by the way. So at this point, I was going to put up the unemployment rate and show you that. So I really need this to work, and it's not going to, so wow. So let's quit. You're bored as hell anyway.